We're going to continue to look at shells, but here our axis of revolution will be either a vertical line or horizontal line that's not on our axes. So if we go ahead and graph this, we'd have a vertical line at x equals 4. This is a parabola, but it might be easier to go ahead and solve this for x. So we could go ahead and take the square root of both sides, and then we could go ahead and add 2, and we get this. Now it's really plus or minus here, but because I know I'm dealing with my y's being between 2 and 4, I know I'm going to be dealing with the positive root, not the negative root. So then we have a horizontal line at a height of 2 and a horizontal line at a height of 4. So if we graph that, we would get horizontal line at 2, horizontal line at 4, our x is equal to 4, and then we'd have our sideways parabola, the top half of it. So when we shade that region, we get this region. We're revolving it around your axis of symmetry, which happens to be denoted here by your x is equal to 4 in orange. So our bounds, because we're dealing with a vertical axis of revolution, we're dealing with x's. So we know we're dealing with x's, so your bounds have to be how far left and right it goes. It starts at 0, goes all the way over to 4. So your radius is going to be going from your axis of revolution into your shaded region. So it's either x minus your axis of revolution or axis of revolution minus x. Remember, it's always bigger minus smaller, so it's going to be right, which is 4, minus what's on the left, which would be x. So x minus 4 is going to be your radius. Now your height has to be perpendicular to that, and it's going to go top minus bottom, or big minus small. The big is your parabola, which we have right here, minus what's on the bottom, which is 2. So it's our parabola with a minus 2. Well, in this case, the 2's in the parentheses drop, and we have this. Then we can distribute through our x to the 1/2, and we would get this. Now at this point, it's pretty easy to integrate, leaving our 2 pi in front. Now all we have to do is plug in 4 minus what we get when we plug in 0. And I would probably go ahead and type this into my calculator, multiply it by 2, fractionize it, and put a pi by it. And we would get this. So here we would have another parabola again. We'd have a second parabola. So we have 2 parabolas that we're looking at. However, for the sake of graphing, it might be easier to get y on one side by itself. So you could square both sides. No, wrong one, sorry. Square both sides, we get this. Add your 2 to both sides. So we know it's a parabola opening up, vertex of 0, 2. Here, this one, we could go ahead and factor the right-hand side, factors into a y minus 2 and a y minus 2. Now, if we get y by itself, we could take the square root of both sides, and then we could add our 2. So now, if we would graph those, we would get this shape right here, and we're revolving around our y is equal to -4, which is over here. It's a vertical axis of revolution, so we know we're going to be dealing with x's because of this. Dealing with x's, it has to be how far left and right your shaded region goes. Starts at 0, goes over to x being 1, so those happen to be our bounds. Now your radius would be this. It has to go from your shaded region to your axis of revolution. We know our radius is either axis of revolution minus your variable or variable minus axis of revolution. Our axis of revolution is on the left, so we know it's going to be x minus our -4. So x minus our -4. Then your height has to be perpendicular. Notice how it's going to be top minus bottom. It's going to be the blue minus the red. The blue is what we have right here, a square root of x plus 2, minus the red, which is your x squared plus 2. Notice when you distribute through the negative, your 2's are going to drop, and we have this. So we now have 2 terms times 2 terms. To be able to integrate this, it's going to be easiest to have this FOILed out. So you FOIL that out. Now it's in a form that's pretty easy to integrate. Increase your exponent by 1, undo it in front. Plug in your 1 minus what you get when you plug in 0. Type all this into your calculator right here without the pi, turn it into a fraction, and know that you're going to have a pi hanging out by it. Here, we need to go ahead and use shells again. We're dealing with another parabola, y is equal to 0, which is your x-axis. X is equal to 2, and we're revolving around y is equal to 1, which is a horizontal line. Horizontal line, or axis of revolution, we know we're going to be dealing with y's. If we graph this, we would have our parabola. We'd have our x is equal to 2. We'd have our x-axis down here, so we're looking for the shaded region that's bound by all 3 of those, which is what's here in green. Your radius is always perpendicular to your axis of revolution going to your shaded region. Notice here, when we're looking at our radius, it's going to be what's on top, our axis of revolution, minus what's in the bottom, so it would be 1 minus our variable, which is y. Once again, we are dealing with y, so your bounds are how far up and down the shaded region goes. Starts at 0, goes up to a height of 1 for your bounds. Now, we need to go ahead and figure out the height of the shell, which is perpendicular to your radius. But we're dealing with y, so we need to get x by itself. Well, I could go ahead and square both sides on this. And I get this here, get x by itself, and I get a negative y squared plus 3. So for my height, it's what's on the right, my parabola, minus what's on the left, which is 2. So it's my parabola, the negative y squared plus 3, minus what's on the left, which is my 2. Notice we can simplify what's in here. Now we need to try to integrate this. We have 2 terms by 2 terms, so we'd want to go ahead and FOIL that out. Now it's in a form where it's pretty easy to integrate. So increase your exponent by 1. Now plug in your 1 minus what you get when you plug in your 0. And we end up, in this case, getting 5 pi over 6. So here we're doing shells again. We have another parabola, a second parabola, and we're revolving around y is equal to negative 3, which is a horizontal line at a height of negative 3. Well, these are both y equals. It's pretty easy to graph those. We know this would be first one would be a sideways parabola. The other would be a right side up parabola. So here's our right side up parabola in red. That's this one here. Our sideways parabola here. We're looking for what's in between those two. That's that shaded region. Here's our axis of revolution down here in dotted orange. So since we have a horizontal axis of revolution, we know we're dealing with y's. So your bounds have to be how far up and down the shaded region goes. It starts out here at 0, goes up to a height of 1, so that's our bounds. But we're dealing with y's, and so that means we have to go ahead and get x on one side all by itself here. So I'd have to go ahead and square both sides to try to solve this for x. Then I'd have to add 1 to try to solve it for x. Well, this one here, when I factor the right-hand side, I get an x minus 1 and an x minus 1. So I get y is equal to an x minus 1 squared. To try to solve it for x, I can take the square root of both sides, and then I can go ahead and add 1. So I needed to solve each one of these for x's, so I'd have a formula with y's in it that I could use in my problem because I'm dealing with y. So your height then has to go from your shaded region to your axis of rotation, axis of revolution. So we have to go top, which is our variable, minus bottom of negative 3. So y minus the negative 3 or y plus 3. Your height has to be perpendicular, so we got to take what's on the right, which is the red, minus what's on the left, which is the blue. The red is what's here, so that's on the right, minus what's on the left is the blue, and that's this right here. Well, I could go ahead and distribute through my negative sign, and in that case, the ones are going to drop. So now I have 2 terms times 2 terms, so I'm going to FOIL that out so that I can easily go ahead and integrate. So now I can integrate, increasing all my exponents by 1. Now I can plug in 1 minus what I get when I plug in 0. And in this case, I would get 23 pi over 10. And we have a polar bear in a blizzard.